As you will learn throughout this course, mathematicians love precision and mathematical language is extremely precise. But sometimes we have some conventions that could be strange for people who are not familiar with our language. And this is the case of hidden quantifiers in conditional statements. Let's take a look at an example. We're going to study this sentence. It says that if x is positive, then x squared plus 4x is positive. Now, x is a variable, so the hypothesis and the conclusion are not statements. Then, what numbers can we use for the variable x? Well, if x is equal to 2, x squared plus 4x is 12, which is positive. If x is negative 2, x squared plus 4x is negative 4, which is negative. Now, does this mean that the conditional statement is false? No, not really. Remember, here negative 2 is not greater than 0, so the hypothesis is false, therefore the whole statement is true. So, yeah, it's not false, it's actually true, and we can substitute any real number into that sentence, that predicate, to obtain a true statement. So what we actually have here, what we actually meant is that for every real number x, if x is positive, then x squared plus 4x is positive. So what I'm saying here is that conditional statements often contain a hidden universal quantifier. When we write or say p of x implies q of x, we actually mean for every x, p of x implies q of x. And this is very important to keep in mind later when we're doing proofs and when we're negating conditional statements. But we'll worry about that in another video. Okay, let's take a look at this example. So we have the statement, if n is a prime number, then n squared plus n plus 73 is prime. Again, what is n? I don't know, it's not fixed, we have no idea. So we need a quantifier, and as we said, well, the hidden quantifier here is a universal quantifier, and what we mean is actually that for any integer, and here I'm using integers because, well, prime numbers are always integers, so it makes more sense to say any integer than for every real number. So for every integer, if n is a prime, then n squared plus n plus 73 is prime. And we can rewrite this statement actually into a simple quantifier, universally quantified statement. We can say that for every prime number n, n squared plus n plus 73 is prime. And even if we let p be the set of prime numbers, we can rewrite it as for every x in p, for every n in p, n squared plus n plus 73 is prime. And I will leave for you as an exercise to try to determine whether this statement is true or false. It's actually a quite fun exercise, so think about it.